Module 9, Acid-Base Chemistry, the dilution equation. Calculating molarity is a great way to determine concentration, but we actually need more information for acid-base chemistry. This is because acids and bases are not usually made by measuring a specific amount of grams and then adding that to water to make a solution. Think about it. If you are thirsty and you want to make some lemonade, you know you need lemon juice and sugar. So do you just add sugar to straight lemon juice? No, the lemon juice is too strong. It's too lemony. So you have to mix lemon juice into water and then add the sugar to sweeten it, right? The lemon juice would just be too strong without the water. Well, dissolving the lemon juice into the water is actually a chemical procedure. It's called a dilution. You see, a better way to make acid and base solutions is by dilution. A dilution is when you add water to a solution to decrease the concentration. A good example of this is when chemists purchase hydrochloric acid, they usually buy it concentrated as a bottled liquid. The concentration of hydrochloric acid in these containers is 12.0 molar. So if a chemist wants to make a 2.0 molar solution of hydrochloric acid, it's much easier to dilute that concentrated solution than to measure out a specific number of grams of hydrochloric acid. This means that he will take a small amount of the concentrated acid and add water to it. But he needs to know exactly how much of the original solution to use and how much water to add. This can be done using a dilution equation. M1 times V1 equals M2 times V2, where M1 represents the original concentration of the solution and V1 is the volume of the original solution to be diluted. M2 then is the desired concentration and V2 represents the final volume you want. Look at some examples with me. A chemist wants to dilute 12.0 molar hydrochloric acid to make 500.0 milliliters of a 3.5 molar hydrochloric acid solution. How will he do this? The problem tells us we need to dilute the original solution, so we can use the molar dilution equation. The original hydrochloric acid concentration given to us is 12.0 molar, so that will be our value for M1. The chemist wants the final concentration to be 3.5 molar, so that will be our value for M2. He wants to make 500.0 milliliters after he's done the dilution, so that will be our final volume, or our value for V2. We just need to figure out the original volume to dilute, or our V1. We can set up our equation so that we are solving for V1, and we have 3.5 molar times 500.0 milliliters divided by 12.0 molar. The molar units cancel, so our V1 value is 1.5 times 10 squared milliliters. Our answer needs to have two significant figures. Now the question asks us, how will he make the desired solution? The answer is that he needs to take 1.5 times 10 squared milliliters of the original 12.0 molar acid solution and dilute it with water until it reaches 500.0 milliliters of volume. Then he will have 500.0 milliliters of a 3.5 molar solution. Here's another problem. A chemist takes 2.5 liters of 5.6 molar sodium hydroxide and dilutes it with enough water to make 10.0 liters. What is the new concentration of the sodium hydroxide? We will use the dilution equation again. We're given an original volume of 2.5 liters. That is our V1. And we're also given an original concentration of 5.6 molar, so that is our M1. The chemist dilutes this material with enough water to make 10.0 liters. That is the final volume, or our V2. The question asks us what the new concentration is. Well, using our dilution equation, you can see we have all the values except for M2, which is the final concentration, which is exactly what we're looking for. So setting up our equation to solve for M2, we get 5.6 molar times 2.5 liters divided by 10.0 liters. The liters units cancel, and we get 1.4 molar as our final concentration.